Alright, y'all, I know the picture quality is not super great. This is a labor of love because it is 5 a.m. and I am doing this for you, so please appreciate that effort and just do your best today while you're studying for your test tomorrow. Okay, so the first questions in each section are just to make sure you know everything you need to know to be able to answer and work the actual problems. So our first question here, what does f of n minus 1 mean? Remember that whole thing just means the previous term. Why are recursive equations more difficult than explicit? So remember, explicit equations you can plug directly into, and recursive equations you have to count up. So also this note at the bottom, this is just different notation. A of n is the same thing as f of n, and if you see a with this little n minus 1, it's the same thing as f of n minus 1. You can fix those if you want to. I'm just letting you know that notation is going to look a little bit different. So let's dig into some problems. All right, so question 2 here. They want us to find the first 4 terms in each sequence. So this is an example of a recursive because it's got this f of n minus 1, which means that my pattern is just to multiply by negative 5. They're telling me to start with 0.2. So 0.2 is my first term. That's f of, right, if we say f of 1 is 0.2, and then f of 2, if I multiply this by negative 5, should give me negative 1. And then f of 3 is going to be positive 5, because I'm multiplying negative 1 by 5. And then f of 4, so again, I'm multiplying every time by negative 5 times negative 5 times negative 5. So my next one's going to be negative 25. All right, question 3. This one is an example of an explicit equation, which means I can plug right in. So f of 1 is going to be 1 squared minus 3. That's just 1 minus 3. That's negative 2. So we'll say f of 1 equals negative 2. F of 2 will do the same thing. 2 squared minus 3. 2 times 2 is 4. Minus 3 is 1. So f of 2 equals 1. If we continue this pattern, we should get that f of 3 equals 6 and f of 4 equals 13. To get credit on this assignment, since you have these answers, make sure that you're showing work for how to get all of the answers. Not just the ones that I have work shown for, but these additional answers as well. All right, so there are 2 instructions on this problem. First, it asks us to find the common difference, which is just the pattern. Remember here, our rate is the value that's with the variable. So our rate, or our common difference, is going to be 10. And then they ask me to find the term that's given, which you can't tell on mine, but they're asking for the 40th term. Since this is an explicit equation, I can just plug right in. So I'm going to say that f of 40 equals negative 50 plus 10 times 40. All right, we work that out. We got to multiply first. Negative 50 plus 400 is going to give me 350. So the way we're going to write our final answer is that the 40th term is 350. Or you could say f of 40 equals 350. I'll accept either of those answers. So remember, there's 2 parts to these problems. So question 5, again, the common difference is the same thing as the rate. That's what that means. So when I find the common difference for 5, it's going to be the rate of minus 2. Then this one says which term. So it's not asking for the negative 7th term. It's saying when will this equation equal negative 7. So that's how we're going to set this one up. All right, then if we solve that out, minus 41, negative 2n equals negative 48, which means n, when I divide, is going to equal 24. So what that means is that the 24th term is negative 7. Or in other words, f of 24 is negative 7. So see the difference there. I'm not actually plugging negative 7 in. I'm trying to figure out when will the equation equal negative 7. That's why negative 7 isn't inside the function when I write it there. All right, let's look at the next set. So now we're talking about arithmetic sequences. We've kind of already answered some of these questions. So what makes a sequence arithmetic? You all know that. Adding or subtracting the same amount each time. Mathematicians are weird because they start counting at 0. What is a question asking for? If it asks for the common difference, which we just answered, right? It's asking for the common difference. It just wants to know the rate. What's the pattern each time? All right, the next section, so this one is important because we haven't really looked at this in this format before necessarily. So we want to know which ones are arithmetic. That means, are they adding or subtracting the same? So I'm going to answer the easy ones first. Like 8 is not arithmetic because I can tell that's not adding or subtracting the same amount each time. Number 10 is arithmetic to me because I can tell that it's got a value of +4 as the rate. So this is +4 as the rate. So this is, yes, it is arithmetic. Let's see, is there another one? This question 11 down here is also arithmetic because it says that I'm taking the previous term and I'm adding 100 to it each time. So the rate is +100. So that's going to be a yes. Now, some of these other ones are a little more tricky to check. So I know I'm kind of hopping out of order. I'm just trying to give you the best explanation I can. Question 12 says you're adding n each time, which is not going to be the same amount because you're changing terms each time. So since you're adding a different amount every time, this one is a no. Question 9 says you're multiplying the previous term, and we've never had n-1 in an exponent, so this one's going to be a no. And then question 7, think about when you add or subtract fractions. Remember, you have to have the same denominators, so that's something that we need to do here. Another way to do that is, you all in general, we say we don't like fractions, so we can just try to get rid of them all, which we talked about the easiest way to do that would be to multiply everything by the highest denominator. So if I go through and I multiply all of these by 10, and I simplify all of them. So if you haven't done that, I want you to pause the video, multiply all these by 10 and simplify them and see what you get. All right, so this is what I got when I simplified. You're probably going to have more work shown than that because you all have to work those things out to simplify them. Now that I look at this pattern, now that we've gotten rid of the denominators, notice every time this does actually have a pattern, and it's arithmetic because it's adding by 5 each time. So this actually is another yes, it's arithmetic problem. All right. Hopefully that section makes sense, but if it doesn't, you need to probably watch it again to get the help that you need for your test tomorrow. All right, so the explicit formula, that's where we write everything together in one formula. So remember, mathematicians are weird. They start counting at 0, not at 0, but the 0th term, and we also have to find the rate every time. So this first one is +100, and that means if I subtract 100 and go backwards, I should be at -96. If you haven't done this so far, that's what you need. You need to pause the video and at least find the pattern and the starting point for questions 13 through 16. All right, now when we write the explicit formula, we just say it's the easier formula because everything's all in one. F of n equals the starting point, -96, plus the rate, and since 100 is a rate, we have to put a variable with it. All right, the same for question 14. So my starting point on question 14 should be, well, that's interesting. It is 14. We're subtracting 8 every time. So my function is going to be f of n equals 14 minus 8n. All right, question 15. So on 15, same idea. We need to have our starting point and our pattern each time. So I'm, that's not what I meant to have. Subtracting 100, so my starting point is going to be 102. And this other one, it looks like we're adding 2, so my starting point is 27. So recursive has two parts. First, we have to actually say where we're starting. So I'm going to say f of 0 equals 102. And then we're going to say what the function actually is. F of n equals f of n minus 1, and then the pattern, which is to subtract 100 each time. You're going to really need to memorize that format so that you can write problems correctly on your test tomorrow. All right, and 16, f of 0 equals 27. Same format, f of n equals the previous term, f of n minus 1, plus 2. All right, these next few questions go together. So if you haven't already read the problem, make sure that you do that. And the problem should always give us a starting point and a pattern in some way, shape, or form. So I know the pattern is to add 12 each time. They tell me if I have one cart, it's 38 inches long. All right, so that means that f of 1 equals 38, and I'm adding 12 to get to the next term. Well, I need f of 0, remember? So I need to subtract 12. So if I write my explicit rule, that's going to be f of n equals, when I subtract 12, that's going to give me 26. So it's going to be 26 plus 12n. So remember, this 26 is coming because I need the 0 term. So I have to count backwards 12, even though that doesn't make sense. Like, it doesn't make sense for 0 carts to be 26 inches long. You have to do that when you write the equation. All right, to find f of 5, you all know how to do that. We're just going to plug in f of 5 equals 26 plus 12 times 5. All right, that's 26 plus 60. So we can say f of 5 equals, what is that, 86? So make sure you write it with that notation. And then 19, it wants you to write a sentence explaining what that means. And what that means, the 5, so that means 5 carts stacked together are 86 inches long. All right, so make sure that you have a sentence that explains what the 5 represents and what the 86 stands for. Okay, the next question is very, very similar. If you haven't had a chance to work the next question, pause the video and try it on your own before you watch how to do it. Okay, so this next question, they tell me that your starting point, well, I don't know why that happened. They tell me that our starting point is 100 miles away. And they tell me that they run at a pace of 8 miles per hour. So this is f of n equals, now this time I can start at 100 because the 100 is like the 0 mark on the clock. Think about that, like no time has passed. So 0 starts at 100. And then if you're running towards the finish line, you're actually, the amount of distance you have left should be going down. So this is really minus 8n. Okay, and then f of 7, so if we plug that in, f of 7 equals 100 minus 8 times 7. Now, if you all you needed was the equation and you can work out the other two problems, pause the video and work those out before you watch the solutions, and then you can just check. All right, that's going to be 100 minus 56. So f of 7 is going to equal, what's that, 44. So what does that mean? That means after 7 hours, the runner is 44 miles from the finish. So it's not that they've gone 44 miles. Remember, we're counting down how many they have left. So there's 44 miles away from the finish line. All right, next section, arithmetic sequences. How do discrete and continuous graphs look different? So remember, they look different because discrete are disconnected and continuous are connected. Which one means you're counting in whole numbers? You should have picked discrete. And then what 2 or 3 things make an equation not linear? So exponents on the variables, right? So x squared or y squared, not on numbers, but on variables. Variables on the bottom of fractions, that's the second one. And the third one, if you ever see it, is if x and y, or any variables that, for that matter, are multiplied together. So if you see one that says like 3xy, that's not linear, okay? If you aren't given the domain, that means the domain is all real numbers, which means it's continuous. So we're going to have to connect it. And we need to pick 3 values. Remember, the 3 values you want to pick are a positive number, a negative number, and 0. Also remember, if you're picking values for fractions, you need to pick numbers that are divisible by the denominator. And then solutions are written as ordered pairs. So if it asks for solutions, you need to be writing 3 or however many requests ordered pairs. So you're writing answers in like this X, Y format. All right, let's dig into some problems in this set. All right, so here we've been given a bathtub that starts with 2 gallons of water. So at the very beginning, it has 2 gallons already in it, and it fills up at a rate of 6 gallons per minute. So I've got a rate here. That also give me an equation if I wanted to plug in, but if the rate is 6, that means it's increasing by that each time. So that's going to give me 8, 14, 20, and 24. All right, determine the common difference. So remember, common difference, that was a question earlier. What does that mean? It means the rate. So the common difference is 6. What does M stand for? Well, it says 6 gallons per minute. So M stands for the number of minutes. Hopefully this part's easy because we've done this quite a lot now, it feels like. What's a reasonable domain? So the question really is, should we include 0 based on this? So does it make sense that at a 0 time limit, you could have 2 gallons in the bathtub? Well, yes, it does. You could have 0 gallons in the bathtub, so I'm going to say 0, 1, 2, ... And actually, this one maybe shouldn't have a ... because it says just for the first 4 minutes. So maybe I should just list them and stop at 4. And then the range, remember, range are just y values. So I'll just list my y values there. 2, 8, 14, 20, 24. All right, is this function discrete or continuous? So I know I have these different points. I want to think about how am I going to be connecting them. So the first thing I want to do is plot the points from the table. So I'm going to pause the video and I want you to do the same and try to graph those. All right, now when I graphed them, I noticed a mistake, and you may have been wondering for a while. This 24 should be a 26. The reason I noticed the mistake is because when I originally plotted it, I noticed that that point wasn't quite in line with all the others, and I know that I'm supposed to be getting a straight line. So just know, if you ever get points out of order, you're going to have to figure out maybe what you did wrong, okay? So back to the question, is this discrete or continuous? So we're talking about the amount of water over time. Well, neither of those have to be counted in whole numbers, so I'm going to say this is continuous. So then think, what does my graph need to look like? It means we need to connect these points right here. So the reason I picked this problem was to show you that you can't just copy the domain and range numbers from the graph. You need to think about, like, from the table where the actual points are hitting. Like this is at 2 and then 8, not the 4, 8, 12, 16 that you see on the side. And I'm showing you that because in your book, they all seem to just follow the graph almost too easily. They were too simple yesterday. All right, label each as discrete or continuous. So we already talked about what those two mean. If you don't know right now, you need to go back and watch that part of the video or check that part of the notes that you took just a minute ago. So discrete or continuous. So hopefully you've paused the video and you've already tried these. All right, distance over time, that's continuous. Number of students that asked Ms. Williams if she's graded the test. It happens continuously, but this is a discrete situation because we're talking about the number of times. You can't ask me like half of a time. The number of problems completed, I'm going to say that's discrete because we're saying completed, not the number of problems like you're working on, but if it's completed, either it is complete or it isn't complete. So that's going to be a whole number type of situation. The height of a dog related to its weight, that's continuous because you could have a dog can be in the middle between height and weight. It doesn't have to be like whole numbers. Okay? Last page, woohoo. All right, all of these are asking us to graph, and you may have noticed they don't give us domains, so that means our domains are all real numbers, and this is going to be continuous in the end. So we're going to have to connect it. Don't forget that tomorrow. List 3 solutions. So remember, solutions are our ordered pairs. And so because this is all real numbers, we have to pick values. And if you have a fraction, remember you want to pick the fraction based on the denominator. So the numbers we want to pick are multiples of 5. So just to keep it simple, I'm going to pick -5, and then let's do f of 0 and f of 10. Oh, not, well, I can do 10. I was going to do +5. So we're just plugging in here. -1 over 5 times -5 plus 2. So you're multiplying. Remember, it's the top of fractions that multiply. So that gives me +5 over 5, because negative times negative is a positive, plus 2 equals 1 plus 2. That equals 3. So my solution is -5, 3. All right, if I plug in 0, so once you get the hang of this, I want you to pause the video if you haven't already worked these out and work out this problem. Because if you just watch me, you're gonna wish that you had me tomorrow, and you aren't gonna have me to answer questions. You're going to know that you can do it on your own. All right, this one's 0 is always easy. Anything multiplied by 0 is easy as 0, so that's 0 plus 2 equals 2. So this solution is 0, 2. And then f of 10 is -1 over 5 times 10 plus 2. That gives me -10 over 5. Remember, I'm multiplying the top. That's -2 plus 2, so that gives me 0. So this is 10, 0. All right, so when we go to graph, we've got -5, 3. Remember, I'm hoping, really hoping, that my graph ends up in a straight line. 0, 2. And 10, 0. What am I graphing wrong? Oh, I can't count. That's what I'm graphing wrong. That I graphed -5, -3. We need to graph -5, +3. All right, and then 10, 0, that runs off my graph. So if we do that, you can just kind of make room on your test tomorrow for where it should fit. And you should notice that that is going to make a straight line, and it's continuous, so we want to go back and actually connect it. You're going to get counted off if you leave it unconnected tomorrow. All right, question 32, very similar, except we need to solve for y first. So if I solve this for y, I'm going to subtract x from both sides. So y is going to equal -1 minus x. And then we got to pick 3 numbers. I'm going to try to keep it really simple this time. So let's do, I don't know, f of -2, f of 0, f of 2. All right, so f of -2 is going to equal -1. Now this is minus, and then the x is -2, so that's minus -2. That change, right? Minus negative is positive. So that's going to give me +1. So my first ordered pair, or solution, is -2, 1. All right, my next one, I'm going to do -1 minus 0. That's just -1. So my next ordered pair is 0, -1. And then -1 minus 2 gives me -3. That's 2, -3. All right, so when I go ahead and plot these points, -2 and 1, 0, -1, 2, -3. Those should look like they're in a straight line. Oh my gosh, I just can't read. That's my issue. 2, -3. So now they're in a straight line, and we want to make sure that we connect them. All right, so that looks like a continuous graph. I know that's not super beautiful. All right, last one. We're almost there. Remember, we got to get y by itself. So I'm going to subtract 3x from both sides. -2y equals 6 minus 3x. And then divide by -2. So I'm going to have y, or we could even say f of x if you rather that format. Remember, they mean the same thing. Equals 6 minus 3x, all divided by -2. So I'm going to pick my 3 values. Remember, now I need things that are divisible by this -2 value down here. So I'm going to do f of, again, let's keep it simple. -2, f of 0, f of +2. Okay, so this one's a little trickier, not because not because it's different, but just because of the fraction. So 6 minus 3 times negative 2 divided by negative 2. Remember, if you can work these out, don't watch me do it. Do that on your own, and then just check that you're right so that you know you're ready for tomorrow. Okay, that's 6 plus 6 divided by negative 2. That's 12 divided by negative 2, which is negative 6. So my first solution is negative 2, negative 6. For my next one, 6 minus 3 times 0. I love 0. It's so easy. All right, that's just 6 minus 0, which is 6 divided by negative 2. That's negative 3. So that's going to give me 0, negative 3. All right, last one. This time I've got 6 minus 3 times 2 divided by negative 2. That's 6 minus 6 over negative 2. Oh, they gave us another easy one. 0 divided by negative 2 is just 0. All right, so this time I'm going to have 2, 0. So if I go to plot those, remember these are what we call solutions. Don't forget that. These are the solutions. If I plot them, hopefully I get this one right. Third time's the charm, right? Negative 2, negative 6. It's down here. 0, negative 3. 2, 0. Ah, ta-da! It's a straight line, so I know that I did all that math right. And I'm going to connect them because the domain is all real numbers, so it's going to have to be continuous. All right, watch any part of this that you need to again. Make sure that you are as prepared as you can be for your test tomorrow. If you need help, you might be able to go to see Miss Sharp, who is right next door. She may be able to help answer any questions that you have if you are really struggling and this video is not helping you.